Okay, welcome back. We are looking at chapter 8, section 8.1 and 8.4, and so we learned a bunch of things here. We went over the new concepts which are related to confidence interval, and now we are going to look at examples. So, first example here, a college student researching study habits collects data from a random sample of 250 college students on our campus and calculates that the sample mean is 15.7 hours per week. If the margin of error for her data using a 95% level of confidence is, so the margin of error is E, which is equal to 0.6 hours, construct a 95% confidence interval for her data and then interpret your results. So, now we are given that n is 250 mean. So, this is sample mean, so which means it is x bar our level of confidence is, so C is 0.95, E is 0.6. So, now we have to construct a 95% confidence interval and then we have to interpret it. So, note in this problem, because we are given E and we know that the point estimate will be x bar. So, point estimate for mu is, it is equal to actually x bar and the value is 15.7. So, what do? I do 15.7 minus 0.6, which is equal to 15.1. So, this is the lower bound and then we do 15.7 plus 0.6, which will give me 16.3. So, that the confidence interval is 15.1 comma 16.3, or 15.1 is less than mu is less than 16.3. So, how do we interpret? So, we can say we are 95% confident that the true population mean true value of the population mean okay, mean for what? So, we were talking about studying on campus, right? So, if you can mention what what this is about, so then it is a good idea, but even if you wrote the population mean is between 15.1 to 16.3 hours per week. Okay, next example, it says a graduate student wishes to know the proportion of American adults who speak 2 or more languages. He surveys 565 randomly selected American adults and finds that 226 speak 2 or more languages. So what are we given? We are given n 565, that is n. So what is this 226? Well, this is a value, so we can say this is x. Now notice here no mean is given here, no the word mean is not present, so it means it is, and we have a kind of a total and a subset or subgroup, so this means we need proportion, because this 226 is coming from this total, so this you will get, this is a statistics, which means it's p hat. So p hat is 226 over 565, which comes out to be 0.04, 0.40 or just 0.4. So it says estimate the proportion of all American adults who speak 2 or more languages. So this is the estimate. So now we can say we estimate that this is not, we did not create a construct a confidence interval, but we the question is asking, we are answering that. We estimate that the proportion, or that 40% of American adults can speak 2 or more languages. So that's it. Okay, looking at example 3. Researchers want to estimate the mean monthly electricity bill in a large urban area using a simple random sample of 100 households. So n is 100. Assume that the population standard deviation is known to be, so sigma is 15.50. Find the margin of error for a 99% confidence interval. So C is 0.99. Okay, and now we have to find the confidence interval. So the first thing we do, notice here no E has been mentioned here. So E is not given, which means we will have to calculate the E. So then what are we talking about in this problem? Are we talking about the proportions or the mean? So because standard deviation is given and it says estimate the mean monthly, so we are looking for the x bar. Okay, so not, it is again, this question is not asking us to construct the interval, but we have to find the margin of error. So what is the formula for E? You have to go back or open your notes and you may find it. So does it say Z alpha over 2 multiplied by sigma over square root of n. So how do you find Z alpha over 2? Well, immediately from here you can say alpha over 2, Z alpha over 2 equals, and we look up at the small table. So alpha will be 0.01. So I don't even have to divide that by 2 to find alpha over 2, because the table, it gives you the value of alpha here and then z alpha over 2. So in terms of c is the last value, in terms of alpha also it is the last value. So the value is 2.575. So z alpha over 2 is 2.575. So we will take that, plug it in here, and then sigma is 15.50 divided by 100. Take the calculator, plug in the numbers, and you will see you get 3.99125. But the question said round your answer to 2 decimal places. What does that mean? This will be equal to 3.99. So E is equal to 3.99. Okay, next example. A survey of 345 randomly selected students at one university is found to be 301 students think that there are not enough parking. There is not enough parking on campus. Okay. So our n is 345, and what is that 301? That is some x. There is not, okay, find the 90%. So 90% means C is 0.90 or 0.9, and we have to now construct the confidence interval for the proportion. So which gives us the idea that we have to find p hat, which now will be 301 over 345. And when you take out calculator and simplify, you get 0.87. Okay, so now we need to find E, but for E we need z alpha over 2. So from here, or you can go this way maybe if you have space. So it means alpha is 0.10, which implies z alpha over 2 is 645. And why is like that? Why not 2 digits? Because remember, this is a value which is coming kind of what we say on the cusp. So there is a number. So we wanted the value to be 0.9, but what we saw 9000 if you want to write in 4 digits, and then there is a value 0.8997, and there is a value 0.9003. So both these values are close to 0.9, and both have a difference of 3. So in this case, what we will do, we will take the z with respect to this, which is 1.65, and the z with respect to this, so therefore we have to take the average of those two values. 3, I believe. Okay, you can look up. So E will be equal to, because this is now proportion, right? So we cannot apply the same formula for E. There is a different one which says, so plug in okay, why am I using 0.87 here? This is P, right? But we have P hat here. But remember, best estimator or estimate of P is 0.87. So that's why we need the P in the formula, but we are actually using P hat. So when you do the calculation, you will see that you get 0.03. So that is the error. So now what we do, P hat minus E, which is going to give me 0.87 minus 0.03, which gives me 0.84. Then I do P hat plus E, 0.87 plus 0.03, which will make it 0.9. So now we say that the confidence interval is, so as before you can write in interval notation, or you can write as in P. This is a proportion problem. Okay. Now we have the confidence interval. Now we need to interpret it. So we are 99% confident. No, 90%, right? So we are 90% confident that the true proportion of students is saying there is not enough parking space on campus. It lies between or is between 0.84 and 0.90, but you can also say is between 84% and 90%. So this is how you do these problems. Okay, we have the next topic here, minimum size for estimating population mean and minimum size for estimating population proportion. So we have these new formulas now for, so I will come back in the new video to go over this portion of the chapter 8.